What is up, people? How's it going? Thanks again for everyone. Thanks again for joining the stream today. Let me get everything checked out in about a minute's time. All right, looks pretty much fine to me, and we can get started. I do see a lot of comments in the chat section from Kamal. Stream topic. Yeah, I'm going to be talking about that in today's session. My audio low. How low is it? Looks pretty fine to me. Okay, is it fine now? Hopefully it is fine because I'm just keeping it super close to my mouth, and it should be fine, hopefully. Hi Sumit, hi Kamal, thanks again for joining everybody. So I did see some questions from Kamal. Socket, API development, web services, listen method, servers. All right, all of these seems to be like a specific to backend, and most of these are already documented and available. But for your first question about streams, I'm just going to be starting with that in today's session. So pretty much you guessed it right. We're going to be talking about asynchronous code and how you write asynchronous code with Dart. And so far you've seen about the basics of Dart, right? Like what is a variable, what is a function, and how you create these, and what are classes, and all of these are created. So for this one today, I'm just going to be talking about a few things, the topic of asynchronicity itself, and how it plays a very vital role in writing any type of a program, right? Any kind of programming language. Without the use of asynchronicity, we don't have the flexibility of writing a huge program. So that's what we're going to try to find out in this session. I'm going to be probably targeting a little bit about from yesterday's session, giving you guys a little bit of understanding of what we did yesterday. And today's session, I'm just going to be targeting specifically about asynchronicity, try to give out as much examples as possible, and then we'll get into the topic of asynchronous in Dart in particular. So let me get started, wait for another minute's time probably, and probably they get started from there as well. If my audio is not fine, or if you guys find that my audio is a little bit jarred, or then just drop a comment, so I'll know for sure. Why is my display not working? Okay, yeah, right, everything looks cool. I'll just get started in a minute's time. Like I said, I will just open for AK Pandey. Hi AK Pandey, how's it going, buddy? Thanks for joining the stream. I do find Sumit joining everyday stream. Thanks again everybody for joining. Okay, everything looks fine today. We'll get moving on in about a minute's time. So everybody here who's watching this stream today, do you guys have any idea with respect to what asynchronicity means? So like, what is asynchronicity, what is synchronous programming? Like, if there is a good understanding of those two topics, then today's session will be a breeze for everybody, because asynchronicity is in itself a vast concept. um, each programming language handles asynchronous in a different way, but one of the most popular ways of handling it is by basically pretty much done in Python for a lot of reasons. And also if you take examples of the recent programming languages like Rust and Golang and things like that, these guys do a very good job of handling asynchronous code. And also with respect to JavaScript does a good job of handling asynchronous code as well there. So we'll see what exactly is asynchronous programming in a bit's time. But before that, I just wanted to give a brief understanding of what we did in yesterday's session. So just do a simple recap so that it's easy for everybody to understand, and from there on we can get moving on, and it'll be pretty easy for everybody to pick up from where they left off. All right, so before we begin, like I said, we're going to be targeting in particular what we did in the previous session. So in previous session, we primarily looked into the um, concept of classes, right? And not just any class. We actually did already see classes in previous session itself. But what we did specifically with respect to the classes is that in normal classes you have this concept or this problem of in programming languages like Java, you have bunch of different ways of creating classes, and also Python, everything is in the form of a class and object. Take for example C sharp, again Java, again classes and objects. C++, same stuff again and again. So everywhere you see there's a concept of classes present, and what these classes give out in the end of the day is like a mechanism to hold out bunch of things. Like let's say that you have a huge room here and you want to put everything in a bedroom right here, and you want to put everything in a kitchen right here. So what you're technically doing is you're classing things together um, by giving it a name and putting all the properties and parameters, all the actions into one specific room. And this is exactly what classes also do. They basically trying to put everything together into one specific field, one specific place, and that's what classes are for. So if you want to take more examples, you can actually, we saw yesterday about how classes can be created in Dart using the keyword class. Just use the keyword class, and we also learned how to create that. Following on from here, we also had to little bit understand a little bit about inheritance. And inheritance was already covered in the topic day before yesterday as well. So I just wanted to give like a brief introduction to what inheritance is. And why I'm going again over all these concepts is that because it's again tied together with today's asynchronous concept. So in the concept of inheritance, right, you have only one inheritance allowed, which is called as the single inheritance. So single inheritance is like you get few traits from your father, you get few traits from your mother. And let's say that you have only now one basically one upstream, meaning that you get only traits from your father gets traits only from his father, and things like that goes up and up. And that is the only type of inheritance that is going to be allowed in Dart. This is primarily because we were trying to, or the Dart was trying to solve something called as the diamond problem, wherein if you had multiple inheritances, right, and the multiple inheritances will always give rise to a few problems down the line when you're writing a huge code. There is class A that is inheriting from class B and C, and this B and C here. And what happens after that is that B is trying to inherit from another class D, and there's also another class called E that is trying to inherit from, and it's trying to do that. And as you see again, D trying to again inherit A. Let's say that D is trying to inherit A, and what will happen is that you're stuck in this kind of a loop where A waits for B, B waits for D, D again waits for A, and it keeps on going. And this is often called as the diamond problem, which comes up with the multiple inheritance concept. So they wanted to reduce this completely, and they just said there cannot be a way where there should be always one class at the top, which is going to be like the base class, and you can only go down from here, right? You can only go down, and that's how you can inherit. There is no way that this can again inherit something else. That is not possible. So this was actually introduced, and the single inheritance was again primarily used in the earlier portions of Dart. If you see, right, all the SDKs would have only inheritance allowed. And post that, what happened was there was another concept that we also saw, which is basically the clear frame here. All right. So another concept after that gave rise to the next one, which you saw, was the mixins. And I stopped around the topic of mixins for one specific reason. Why I stopped with mixin was that I'm not a big fan of mixins, to be honest. So why mixins were created was, let's say there's a class A right here, and this class A wants to now have a big class B inheriting from another class B. And what you also want to do is this also should have some properties of few other classes like class C, but this is not allowed, right? One class cannot inherit two different classes. So what they did was, instead of just calling this as a class, they just said that there should be a specific or a special type of class called as mixins. The whole use of this mixins is to just give rise to code reusability. And when I say code reusability, that means that the code is going to be there present, but there is no property of a class. You cannot create an object of this mixin, you cannot instantiate this mixin, and none of that is possible. So that's how they try to solve the problem of multiple inheritance at once. So that's what we saw in yesterday's session as well. And I think we stopped it right there, and I'm just going to be opening for any questions at this point of time. Hopefully, yeah, everything looks fine to me. Yeah, everything looks fine to me. So I'm just going to open for questions at this point of time. If you guys have any pending questions from yesterday, you can just ask me right now. Because suppose this, I'm just going to be explaining the concept of the concept of asynchronous programming in about a minute's time. So if you have any questions so far, anything related to programming itself, you can ask me, and I will just spare about 2 to 3 minutes of time for that, and then we can move on with the concept of asynchronous programming. I'll put a question mark so that you guys know that we are opening for questions. Question mark. I'm going to talk about streams. Come on, just give me about 15 minutes of time. When you say real life examples, I don't understand what you mean by real life examples, but there are a bunch of use cases that you can talk about. So I'm just going to talk about asynchronicity in about 2 minutes time. Once you've taken or yeah, if you guys have any questions, we can. If you don't have any questions, we can move on, but I'm just going to talk about it in about a minute's time. So give me, just be patient enough. But it looks like we can just move on. Probably that's what I understand from the silence from you guys. So just move on. And what I'm going to do is at this point of time, talk pretty much about asynchronicity. And asynchronicity is a very cool concept. And uh, you just have to definitely understand asynchronicity. So this concept of linear time, right? Let's say that this function A starting at one point, and the code is moving from a point A to point B, and point B to point C, and point C to point E, and keeps on moving. This is how our traditional code works. Take the example of Java, take the example of C, and all these older programming languages move in that fashion. But what happens if you want to wait at some point? If you want to pause the program at some point, what if you want to just keep on moving and few things run in the background? This concept of not waiting or not writing a program in an asynchronous fashion is all everything about asynchronous programming. So meaning that if you don't want to do something in a linear fashion, you just want to do something in the future, you want to do something in the past, you want to just wait for at some point of time, all of these are possible when you include the concept of asynchrony, which is asynchrony or asynchronous, however you want to call it. That's what is going to be the whole use of it. So I'll just do some kind of an explanation right here. Let me clear this whole thing up. So what happens is that let's say there's a function A that is going to be present here, and this function A right here is just used for printing some information, and the code moves from top to bottom. That's what I've been telling from the right from the start of this series. So the code here is executed, and then there is another block of code B, and this block of code is trying to like multiply 20 digit numbers, multiply 20 into 20 digit numbers, right? And it's going to take obviously some time. Let's say it's taking probably 300 milliseconds or 400 milliseconds, and you just want to wait for that. I mean, this is how naturally programs work. So this block has to get completed, so 20 into 20 digit program number has to get multiplied, and it is just executing it and coming down from there. And in this section, in this block, it is trying to probably do another set of actions, like printing this entire number. Like let's say there is 400 digit number present, some folks for some example, 400 digit number is present, and what are you expecting here to do is print all the 400 digit numbers from 0 to 400 digit number. So probably let's say that a print action takes about 1 millisecond, so it's going to take 400 probably 400 factorial number of times to finish it. So this is going to take 400 factorial seconds, or sorry, milliseconds, to finish it. So basically that's what these three functions are going to do. And if you just take it in a linear fashion, let's say you are executing it in a C program, and everything the C program does is the compiler is in this side. It sees the block A, and it's thinking that, okay, I'm going to print some information, give it some time. Let's say that starts at 0 milliseconds and it ends at probably 2 milliseconds. So it takes 2 milliseconds for this function to get executed. Then it looks into the compiler looks into the block B, and the block B is now trying to multiply 220 digit number into another 20 digit number. And so the compiler has to do it. It needs to go and access the CPU. It accesses the CPU, access the memory unit. All of these things are accessed, and the compiler is doing all this information and things like that, and it's actually making sure that the code waits at block B. So the code is now waiting at block B, and in the meantime the compiler is communicating all this information to the CPU. It is communicating the information to the memory unit, and algorithmic ALU, all of these are invoked, and finally it is trying to come out with an answer. So let's say that this is now taking from 2 milliseconds, because that's the end of this. So from 2 to it's taking about 300 milliseconds. Let's say 300 milliseconds in total. So it's going to take 300 milliseconds in total. So from point A to point B, you have spent about 300 milliseconds to complete the whole two actions. Now it's moving, the compiler is looking at the C block, and it is saying that I need to print all the 400 digits, like 400 digit number from 0 to the 400 digit number. And it knows that a print action takes about 2 milliseconds, and so it wants to now do this. So it again puts a stop here. It goes back to the compiler, compiler goes back to the CPU. It tells the CPU that we are required to print something onto the console, probably 400 factorial times, and each print actions take about 2 milliseconds. So it's going to wait for 2 milliseconds into 400 factorial times in this section on this block. So that means that you are waiting for approximately 800 factorial milliseconds, from 0 to 800 factorial milliseconds. So that's the total time. Let's say that 800 factorial is somewhere around. Let's take a simpler example. Let's take example of probably let's assume that the whole function takes about 20 minutes to complete, right? 20 minutes for this function to complete, for this whole program to complete, primarily because it is doing something called as a synchronous code execution. It waits for each block to get completed. It only after that block is completed, the compiler is going to release the lock, and only after that lock is released, it's going to move to the next chunk of code. And this is often what you find in all the compilers. I'm not saying that this is actually something new, this is something old. It's present in all the compilers even till date. This is often the basic understanding of compilers. The compilers, all they need to do is look at each line of code and execute them by communicating with the CPU and the memory unit. That's pretty much what the compilers are doing. It is just trying to understand your program and trying to convert it into binary format, and then convert the binary format back into human readable languages. So this is the whole code. This is how your synchronous programming works. So people kept thinking, like, how can a programming language itself by default reduce this code execution? So you are saying that the code from A to B has to take probably 300 milliseconds. But what if I do something like this? So I start at the point A, and by the time B is getting executed, I also want C to get executed. So this is something where you talk about the concept of parallelism and threading, and I'm not going to get directly into all these concepts at this point of time because it's by itself a huge topic to cover. But just think about this. The concept of parallelism is where each block can execute parallelly without having to wait for one another. So that's the whole idea behind parallelism, right? And that's what the programming languages itself are trying to cover. They are trying to, by itself, by nature, when you're building the language, they wanted to have that as part of the compiler itself. And that's when the whole concept of future came into picture. That's when the whole concept of asynchronous programming came into picture. So I'm just going to clear this frame out. So if you guys want to just take a screenshot of this, I'll just clear this frame out right now. Alright, frames cleared, and we're going to be moving into the topic of asynchronicity. And this is where you guys have been asking me, especially Kamal has been asking about streams, which I'm going to tell in about a minute. I'm just going to talk about futures for now. The streams are nothing complex; these are similar to futures, but I'll just cover about it. So asynchronous programming is when you don't wait for anybody. Asynchronicity is coming by itself, by nature, when you're not waiting for a block of code to execute. We'll take the same examples again. So there's a block A present here, there's a block B present here, and a block C present here. Code is again running from top to bottom. So this is the execution code. So A gets completed, it moves to B, B gets completed, it moves to C. This is how the compiler thinks. So the compiler is right here, and this guy is just looking at the code, and he wants to know, you as a programmer wants to make this entire thing asynchronous. You don't want to wait for anybody. So what you're telling is that as soon as the code enters a block and it sees that it's just some print information present, the compiler knows that it's nothing normal, it's just normal stuff. So it's printing the information, takes about 2 milliseconds. But after this gets executed, it's looking at B, and there is something called as an async keyword that is present with this this method. So this method says that this entire block is going to be asynchronous, meaning that there could be some methods inside that could take about 20 minutes to get executed. There could be some method inside that could take even 2 seconds to get executed. But if there is a function with the keyword async attached to it, the compiler understands that this is not something that you want to get you want to execute right now. You just want to leave it as such and just move on. So the compiler sees the async keyword, and it says that okay, so this means that there's a function block here which I don't want to touch, I don't want to wait for it, I don't want to worry about it, so I'm just going to carry on from here. So it just looks into the async block and just jumps to the C block. So now the B is still going to get executed. So the B might say that wait for 2 milliseconds and then do some actions, and so this action might take probably 50 milliseconds, right? So this B is starting at the same time as this gets completed. So at the same after the end of 2 milliseconds, the 50 milliseconds programming gets started, or the 50 millisecond model gets executed, and at the same time C is also getting executed. So let's say the C is now taking about 1 second or 1 minute. So 1 minute starting at the same time as this block is also getting started. So at the end of the day, how long would your program would have take? How long would the whole program take to get executed? Any guesses from anybody who's watching the stream? So yes, I'm saying that B and C are starting at the same time, and B takes 50 milliseconds, C takes 1 minute to get executed. So how much time would the entire program would have taken to get executed? Right, so Sumit says it takes 1 minute, and actually the answer is correct. So 1 minute it's going to take, and include 2 milliseconds as well. So it should take probably 3600 milliseconds and 3602 milliseconds. So 3062 milliseconds is the total uh, time execution of this program. Compare this with the one that we had previously, where it had to wait for it, so it would have taken longer time to get executed. So that's the concept behind asynchronous coding, where you as a programmer, as a developer itself, you're thinking in your mind that this is how I want to write my code. I want to make a function async, so that when I say this code is going to get executed in asynchronous fashion, I'm just telling that this might get executed now, this might get executed in the future, but just don't worry about it. You're telling the compiler that. So the compiler is able to understand that, and the concept of logs comes into picture here. So when you see a async here, the compiler knows that not to put a log, but to put an open-ended lock, meaning that this might still pass some information to the CPU, right? There's a CPU block that is present right here, and the CPU might still pass, and my CPU might still require some information from the code, and this compiler is able to do it in a much better fashion. It's now in a much better understanding of what is happening. So the asynchronous is happening without any flaws, and there's a lot of advantages when it comes to asynchronous code. One, the main advantage is, let's say that you are having this very heavy data streaming happening. So this data streaming is right now happening, right? My laptop is taking the video stream, video encoding part, and it's trying to send it to the YouTube ingest servers. So the YouTube server is now picking this up, and it is continuously putting this data into the as a YouTube video. So far what I have seen is that okay, I'm going to answer Sumit's question, but let me finish this example. I don't know if Kamal is in the stream. Kamal is available for this. Still here, but I'm just going to talk about this. So the YouTube stream is happening. Video is getting picked up from my camera, and it is then setting it to the YouTube ingest servers, and YouTube ingest servers is picking this up and it's converting it into a video, and it's stitching it continuously, and you guys are seeing it. So that's pretty much how the concept of asynchronous works. So asynchronous means that I'm continuously sending a packet of information. I'm continuously sending a video feed of information to the YouTube ingest server, and the YouTube ingest server knows that either for this second I'm going to get some information from this person, and there might be a buffering issue, there might be a server timeout issue, that might be a local internet issue in my system, and your video buffers. So even if the buffer happens, that means that the YouTube ingest servers are continuously waiting for some information. So all of this is asynchronous. There is no stoppage here anywhere. There is no place where the YouTube videos, like you see one frame now, and after 3 seconds the other frame sees, and there's another, say for example 2 seconds later, there's another frame that you see. There's no, like you have mentioned, lagging happening in the video. It is quite smooth, right? And this is happening because of the concept of asynchronicity. If there was no asynchronicity, there's only synchronous way of loading this video, what would have happened? You just take the stream, and even before the stream hits your ingest servers, you keep on see the buffering happening every now and then. The buffering will happen, the video will be so lagged, and you will not stitch properly, you will not be able to see it. And all of these problems can be solved because we are running everything in asynchronous fashion. If there is no video, if there is no YouTube, there is no kind of a video stream package that the servers of the YouTube is receiving, then it will just keep on buffering. But as soon as it receives, it is not sending everything out instantly. It is making sure to stitch things together and then sending it as a YouTube video, so you guys are able to see it. So that's how the whole concept of asynchronicity works. So okay, that's what I wanted to cover, and I just want to answer Sumit's question as well. So at the same time the code is being executed, for a human eye the processor is fast, so they think the code is running at the same time. So okay, you are talking about parallelism and threading, which is, again, like I said, I don't want to go into it. Parallelism is when you have multiple CPU cores executing the same code. Threading is when you have one CPU core running the same code but with multiple different threads. And I just don't want to jump into it and cover most of it because it's in a huge part itself. But if you think as a human eye, right, like you're talking about 1 millisecond, 2 milliseconds, but let's consider 1 hour kind of a program, 2 hour kind of a program. If you take huge models to build, like a machine learning models take 2 days to build. Machine learning models probably might take 3 days to just build the model, just get all the data from millions and millions of sources, try to build it as a simple model. It takes 3 days, 4 days to build. But if you are in a better fashion, if a programming language itself gives you the ability to do things asynchronously, you're just reducing it by a lot of fashion. 50% reduction is there. You can say there's a 20% reduction, there's a 10% reduction, and that's what the asynchronicity provides by itself. And if you see higher programming languages, let's say you are trying, let's say if you are trying to build a machine learning model, and if you see all of these popular frameworks, popular libraries that are available for machine learning, asynchronicity is inbuilt. There is nothing that you can do without asynchronicity. You do not see the concept of synchronous programming at all when you're trying to build a larger project, bigger projects, and that's something that you need to definitely know, and that's the important reason why I wanted to cover it. So this is pretty much the concept of asynchronicity. So there's two important keywords that are that you need to know by for sure. One is the async keyword, which you will definitely see left and right, and there's another keyword called as await, and this is also another important one that you will see. So practical examples here are, let's say you want to open a file, and if you want to open a file, the file is, say, it's about 2 GB in size, right? If it's, you want to decompress it or compress it, and the compression is going to take some time, right? And you want your program to like execute this in a parallel fashion, you want to execute in asynchronous fashion, but you want to wait for it to complete. And if you want to wait for it to complete, you will just use the keyword await. If you're just denoting that a function is going to do something in as asynchronous fashion, you just mark it as async. And that's what you're going to be seeing in the next slide. I just open my dart pad as well, so I just can give you guys like an understanding of this whole thing with programming examples. So hopefully this entire thing should have cleared out a few doubts for you guys. If it doesn't, just drop a comment and I can explain to you again. Alright, so I'm going to move on, and we're going to be starting with the concept of futures in Dart. And futures, like I said, is one of the two important ways that Dart implements asynchronicity. One is futures, and the other is called as streams. Streams is what Kamal has been asking from the start. So the futures, if you understand futures very well, streams are going to be very simple to understand. So let's say the futures, right? As the name suggests, the futures are something like you can think of them as a special type of an activator. I shouldn't use the word activator right here. I should say special type of a keyword that is going to just denote that something is going to happen in the future. So this keyword denotes that a return type in the future might come out from a function. So if you take any examples of streams or futures, you will only put it inside a function. A class cannot have a future operator with it. The class cannot have the concept of asynchronicity with it. A function can only have the concept of asynchronicity. Each individual block of code that is enclosed as part of a function can have the concept of asynchronicity associated with it. So just going to do like a little bit of a deep dive with future and see how the code examples pan out, and we'll see about it right now. Alright, so in Dart, the futures use the async and await again, and the futures are basically for finite number of tools, a finite number of information. So I'll just clear this out and just give you like a brief understanding. And I'm just going to be doing another deep dive tomorrow on the same topic of futures and streams. So I don't want to like really confuse you guys a lot, but I'll just give a brief understanding of what futures are. So futures, as the name suggests, is something like I said is going to happen in the future. And futures, you can think of this as a finite number of data, right? Finite number of data. So 1 to 10. These are the data that you have: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you are telling that in the future, your function A is going to return this data one by one. So what you're saying is that in the future, this function is going to return 1, and after about 2 seconds it's going to return 2, after about 3 seconds it's going to return 3, and it keeps on going till the topic till 10. And after 10, nothing, you cannot expect anything more, because for sure there's only 1 to 10, which is the finite number of data that is going to be returned by this function. So if you have a finite information that is going to be returned, you just mark this function as async after the function name. So a function definition would look something like this: function name followed by a space. So space async. If you mark something as async, you're just telling that this function is going to be happening in an asynchronous fashion. So that's what we're pretty much doing here. So this function is going to be asynchronous, and if there is an asynchronous function, you can either have a void of future, or you should have like a finite in the future. Finite futures like string, integers, or float. So you just mark it as future of either void, or you will have string or int, something like this. So this is going to be also be present as your return type. So these are the few syntactic things that you needed to know, and you just write some code here, and you will for sure see for yourself how this whole thing is panning out right now. Just open to see if there's any questions. Yeah, there's no questions. So just go to .pad.dev. That's what we've been writing our whole code on. Make sure to provide our first void main. This is very important. Without void main, nothing happens. So we'll just say print. This is the start of the program as usual, and we have another print. This is the end of the program, and let's finish it. Now you want to create your first method, and this method is going to be, let's say that I want to call this as a future function. So this is a future function. From the future it's going to return some data, but if you just mark it or leave it just like this, there is no future attached to it. The compiler won't understand that this has to happen in the future. So what you will do is to basically attach the first thing or the first keyword, which is after your open and close brackets. You will just attach something called as async. So just say async and just leave it as just like that. And let's say that you want to do some actions inside, like you want to wait for 5 seconds, and after waiting for 5 seconds you want to return some data. So in order to do that in Dart, you can just let's check time.sleep in Dart. Here you can say future dot delayed const duration. You can just delay the whole thing for a duration of 3 seconds, and the syntactic sugar of a open function. So just say probably 1, right? So what you're trying to say here is just wait for 1 second, and as you can see in an asynchronous function, you just have written something here. So it's future dot delayed constant duration seconds. You've written all this stuff. So technically this is going to just wait for 3 seconds, and after that you're just trying to return something like this. Return let's say I want to return hello, how are you. So as soon as I put this, it just throw an error saying that there is no return type associated with it, and this future function is basically returning a string. So I just want to put like something like string here. So if you put string here, you will find that it will throw an error. The first thing it will say is that functions marked async must have a return type assignable to future. So which means that I cannot just return a synchronous string function, synchronous string variable. Rather I should say it as it's going to be a future string variable. So if you say it is going to be in the future, the compiler understands that it's going to be pretty much something that's going to happen in the future. So what I'll do is just go here and mark this or wrap this entire thing around this kind of a syntax. So say future, the open and close angular brackets are meaning that it's going to be of type string. The future is going to return a type of string. So this is going to be the whole function, and let's take vote now. How many of you think that this function will wait for 3 seconds and then return hello, how are you? And how many of you think that it will not wait for 3 seconds and it will immediately return hello, how are you? So I'm just going to execute or call this function right here. I'm just going to say print. This function is called a future function, right? So future function of, so it's going to execute this and pretty much like this one. This is the start of the program, end of the program, and inside it future function. So I'm just going to do this. So let's say how many of you, let's see how many of you think this is going to take 3 seconds and then execute this function, and how many of you think this is not going to wait 3 seconds and it will just print it in almost instantly. Yeah, so async can be used for IO operations as well. That's why I said, let's say you are waiting for opening a huge file. So IO operations are definitely possible. You can definitely use for that as well. So Sumit says it'll execute immediately because await keyword is not used. Okay, good one there. Let's see if somebody else thinks otherwise. So my question is, will this function get executed almost instantly, or will it get executed probably after 3 seconds? So we just have to see. So for now I only have async attached to it. meaning that this whole thing can happen in a asynchronous fashion. The function inside will happen in an asynchronous fashion. So let's see. So I think we're just gonna go with Sumit's answer, and we'll see how this happens here. Will it wait for 3 seconds? So if you see here, it's just saying instance of a future string. So it's just returning the instance of a future string. So I just need to say of data. I'll say men completed. All right, let's forget about that for now. So what is happening is that this is the start of the program, and the future function when called is executing this function, but surprisingly to our surprising to us, it is not waiting for 3 seconds. It's almost instantly happening. So what you see here is this delay after we click this button is something to do with the web browser loading time, not with respect to how the compiler is working. So after the run is clicked, it's taking some time to just send it to the server and then get some feedback from there. But what you happen to see here is this is the start of the program. Instance is getting almost instantly getting executed. That almost instantly getting executed is not sticking to what we are trying to do here. You want to wait for 3 seconds right now, but it is not doing that. The primary reason for that, like Sumit has pointed out, is because we have not used the keyword await. So if you want to wait for some action even inside an asynchronous method, that's when you use the keyword await. Without an await, the asynchronous method will just do everything in asynchronous fashion. There is no synchronicity within the method itself. It will just split every single line of code inside it into a separate thread, or if you have multiple core CPU, it will put it into parallelism and execute everything in asynchronous fashion. If you want to wait for something, you want to use the keyword await inside that. So if you instead just doing of just passing as future dot delayed, if you use the keyword await, excuse me guys, I use the keyword await and then saying future dot delayed, constant duration seconds 3. I'll just try to, instead of just putting 1, I'll just say print 1. All right. All right, so let's see how this happens right now. Function is here, print. Okay, print is getting executed after such a long time. So you see here, 1 2 3, 1 is getting executed, right? So that's pretty much how the concept of await works. The whole thing will have to wait for the completion. Only after that you will be able to see it. So I just need to make one simple change for you guys to see the whole thing. So let me do that right now. All right, so in here we're just saying future function, just calling the future function, right? The first thing that future function will do is to just return an instance of future. That's what is getting printed here, but I'm not very interested in that. So what I'm going to do now is to say function, the future function which is present here, the future function of, after that I'm just going to call this method called as then, which will accept you to pass your success callback on top of it as well. So which means that if you have a success callback present, you can just pass on to it. So say success, and you just say on error, you will just execute the E, and the E is going to be something like this. If there is error something, you just don't have to worry about it. If there is no error attached to it, you just say print that value. Why is it throwing this error? Okay, I think success callback. let me check here 1 second very quickly. Here the function getting executed. You want to now get the data from it, which is basically the future getting returned. So you need to catch the future getting returned. So that's what you're trying to do now. Just say then value, open the close brackets, and you will try to print this value. So value is, we just print the value. So basically saying if and when the future is completed. So we're just saying if and when the future is completed, this is going to get returned. This is how you catch a future being returned. So future, you're now able to write an asynchronous function using the async keyword that is present here, and this is how you're going to be able to catch the asynchronous function after the value is getting returned. So the value is, if you try to print this now, you will see very clearly how this entire thing works pretty fine right now. So you have this is the start of the program, this is the end of the program also getting executed, but only after you have pretty much done with your await, this function is exiting. So what did I understand from this? When I said that a, this is considered this as a, this is b, and this is c. So a is the starting point, it is entering a, but the future function is marked as an async right here. And if something is marked as async, the compiler will say I'm going to do it in the future, and just put it in the future. And by the and the same time, it will come to the C block, which is the print statement here. It will just print it immediately, and then by the meantime, this function, future function, is completed. It is executing all the things that are inside it. So this is how pretty much you understand or do asynchronicity or introduce asynchronicity into your program, and Dart is very, very famous for that. Hopefully I did cover as much topic as possible. So dot delayed is a predetermined keyword by Dart programming language. Yeah, you can do that. So you're asking about this one. It's actually a part of the future. The future has a delayed function where you can pass the duration up to which you want to delay a function being executed, and then you just add a empty function callback to say what is the function that needs to be printed. So by default, people just, if you want to delay something, you will just say duration of seconds. In seconds, minutes, hours, you can say how much ever you want, and then you need to definitely pass a function callback. You need to either say something, you need to have some kind of an empty return or empty print or something like that should be present, and that's actually a part of the futures, the core library of future itself. So you don't have to worry about it, you can just use the same line of code. Alright, so I'm just going to move to the last topic for this session, which is about the async and await, which I already covered. And one important thing that I also wanted to cover is how this whole thing, right, like how you understand this whole thing and create much better functions. Right, you don't want to do something, you don't want to write clunky functions everywhere, everything doing asynchronous, everything running asynchronously. It will just lead to a lot of program maintenance issues in the future. You have 1,000 lines of code and everything's running asynchronously. It's cool, your program is running faster, but you don't want the program, or you don't want the maintenance nightmare to come in the future, right? So in order to avoid all of that, these are my few important tips that I would give if you want to write better asynchronous functions. Let me clear this out. And in order to write a better asynchronous function, right, always think of these three important steps. Asynchronous function, when you're writing, think of these three important steps. The first step you're going to think is, can this be solved in a synchronous manner itself? So as a developer, you need to decide, do you want to solve this issue in a synchronous manner, or do you want to solve this issue in an asynchronous manner? Let's say that bunch of things are happening, like you want few things to happen in a synchronous manner. Let's say, for example, you are creating an Uber application. Only if the user clicks the destination, only if the user selects the source, after that only you can go and select or choose the ride option, right? If the user is not selecting the source, or if the user is not selecting the destination, you cannot go and offer them a ride, offer them a value, tell them that this is how much it's going to cost. That's just a bad UX program, right? You're just creating a lot of confusion to the user. So these things have to happen synchronously. Only if this step completes, this step should happen. So this is what I'm trying to mean by the first step. Just think if this can be solved in a synchronous fashion. If it can be solved in a synchronous fashion, it should be solved in a synchronous fashion. There is no point in giving asynchronicity to it. Just because it's going to shave off 3 seconds, 4 seconds of, it's going to shave off like 100 milliseconds. You don't want to avoid, or you don't want to create confusion by like not giving it in a synchronous or a step-by-step manner to the user. So this is the first step. The second step is to see how much of this code will be running inside an asynchronous function. How much code will run inside the asynchronous function. Inside function, I'll just write it in a shorthand. So what I mean here is that how much will be running inside function, meaning how much lines of code will be running inside the function. So let's say that you have a huge function, like probably 50, 60, 70, 70,000 lines of code, and you are writing these multiple modules, where each module has probably, each function has 10, 15, 20 different lines of code. And what you want to not do is put a big chunk of code inside an asynchronous function and think probably this is how I'm going to solve it, this is how I'm going to finish it. And if you do that, you are just inviting a lot of maintenance issue in the first place. Second issue is you're inviting a lot of bugs associated with that specific module. So a module is, when you're writing a huge function, you always think of a module as just this 10 lines of code, and that's very easy for us to find where the bug might be. If the bug is to find, let's say that the button click is not working in an Uber application, you need to immediately find out where the module of code that is controlling the button click is, and find out where that actual bug is. If you buried this entire code for button click inside 1000 lines of code, and you've put it all inside an asynchronous function, you are inviting a lot of trouble, because asynchronous function, you never know which line of code is going to get executed when. So just inviting a lot of trouble there. So make sure to always think of how much lines of code will be going inside your asynchronous function. If there is going to be 10, 20, 30 lines of code, see how you can split that into synchronous in one part, and only the core function that you want to execute inside an asynchronous function. So that way you're just splitting the non-necessary items, or splitting unwanted lines of code to a synchronous function, and that's what you're trying to do. So that's the second step. The final step is to obviously see the function call. Where is the function going to get called from? If the function is going to be called from A, B, C, D kind of steps, this is cool. If there's going to be another function that is also synchronous function, the B is a synchronous function calling another asynchronous function, let's call it as E, and this in turn calling an asynchronous function F, calling asynchronous function D. And if you're just introducing asynchronicity inside an asynchronous function, you're inviting again a lot of trouble. So just see where the function is going to get called, and try to avoid asynchronous loopback, which means that a function gets executed only if another function gets completed. You're just inviting a lot of trouble for this. So this is my 3-step pointer that I always follow, not just with Dart. I also follow the same steps with Python as well, where you just try to remove or reduce the number of asynchronous callbacks. Just because you have the power to do something in a parallel fashion, you don't want to overuse it and just make your entire code go broke. So this is going to be the whole idea behind asynchronicity. And in the next session, which is going to be tomorrow, I'm going to be talking about streams in depth. And you just have to definitely understand how this future is working here. Only if you understand the concept of future, you can understand the concept of streams. And streams, when I say streams, just think about how this, you are seeing this YouTube stream running right now. YouTube stream is one of the biggest examples of how a stream can be explained. So I'll just do an in-depth explanation to all of you in tomorrow's session, and I'll just open for questions right now. About another 2 to 3 minutes of time. I just completed it on time, I guess. Yeah, about 3 minutes of time I have. So if you guys have any questions, I'm open to answer them, and I'll be very happy to know how else I can solve all of your problems. Just drop any questions that you guys have, and I'll be very happy to answer them. Let's clear this board. Yeah. Can async lock our program? Asynchronous, very good question. So if you ask asynchronicity can lock a program, it can only lock a program if you if you are using await in the wrong place. As you know, even in asynchronous code block, the asynchronous code block can also wait. You can still introduce wait inside it by using the keyword await, right? If you use this await in a wrong place where there is like an infinite wait loopback, meaning that there is no information that is going to come from the future at all. That's why I said be careful where you use your asynchronous call. If there is an asynchronous function A present, there is calling another asynchronous function B, and this is again calling an asynchronous function C, which is in turn calling A again. You are just introducing a loop here. If you do something like this and then introduce await everywhere, you're just indefinitely waiting for the asynchronous function to exit. Even though the rest of the code will come out, this thing will not come out at all. And that's what I said very clearly in the previous one, where I said um, be sure to understand where you're calling things from. If you're just calling it and indefinitely, and even if you see here, you see that this and this is getting executed even before this is coming out. So all your synchronous methods will execute and also become very huge nightmare for you to debug what is the whole thing about. So this is what this could lock your function but might not lock it indefinitely, meaning that the compiler would at some point kill this whole thing and just exit the whole thing out. But it will become a huge bug nightmare where you will not understand where the bug is coming from. Your function will continuously, one block of the function alone, one block of the app alone will keep on loading, and you will never know why this is happening unless you go in and dig deep and you find what is happening. So it might not lock the entire program out, the entire application out, but it has the capability of probably not producing output at all. That is also something you need to be worried about. Like it might not produce any output in the future also, so just need to be very worried about that as well. So just be aware of how you're using your async and how you're using your await. Which state management provider or blog for good e-commerce application? I already answered this many times, and I do believe that the Flutter itself has a very good state management options inbuilt with the Flutter itself. uh, but if you are specifically building few things, there are a bunch of state management providers. Like provider itself is one state management tool. Block is also there. There's something called GetX, and a block is when you're trying to build something for a large scale. Provider when you're doing something for the small scale. GetX you can use in multiple situations as well, and doesn't matter, right? Like you want to understand how this whole thing, you want to, the whole point of a state management tool or state management concept is to manage the flow of data. And you necessarily just doing the same thing when it comes to creating models and model classes and all of that inside a Flutter program, so Flutter code. So you're just doing a better job. The Dart and Flutter itself is doing a better job, and on top of that you're just doing all of these things for just for fancy purposes, just for maintenance. And in the name of maintenance you're just trying to write complex code, which I don't really like about all the state management providers, state management tools. But my specific favorite one will be Block, because I've used Block for a long time, and even though I don't see much use out of it, it is not going to give a performance boost or anything of that sort. Just for maintenance purpose you can use it. Why does factory used in Dart? Like I've talked about this again. I remember you asked me the same question, but I'll just answer it again. Factories in Dart are for producing multiple different objects without having to create the same object by the processor. Like your CPU is creating CPU is creating the objects for you, and you are necessarily trying to reduce the amount of information that you're going to always send to the CPU again and again to create an object. So what you're doing is you have a class A, there's going to be a class B, there's going to be a class C. You're just going to create one factory class and say that if somebody wants to have an object of class A, you just have to pass through the factory class, and the factory class will in turn produce the object for you. It's reducing the amount of time that a compiler has to communicate with the CPU. It is just doing it all on its own, and it's reducing all the effort it is taking it on your CPU. So it's improving the performance, reducing the memory utilization, and that's what is actually very good about factory. It's actually a design pattern which I might be talking about it into this weekend session on the Unacademy platform. I'm planning on doing like a 2-hour stream there, so if you guys are interested you can check that out as well. What is MVVM design patterns? It is a multi-view view model, which is basically for again there are a bunch of design patterns. Each of these design patterns have different utilities, and I'm just going to talk about most commonly used design patterns in this weekend stream, which is going to be running on the Unacademy platform. I'll talk about that in there in detail. So I'll just talk about that pretty much there. So you just check me out check me out there. Check me out on my YouTube channel, which is Coder Monk. Flutter versus Kotlin, I don't have any opinion on that at all. I've provided my opinion a million times. Flutter is a cross-platform. Kotlin is native. You cannot never compare a cross-platform with a native programming language and native framework. Native is always going to be the winner, primarily because it is producing much faster. It has got much better control over how it can affect your application. Flutter is just a cross-platform toolkit. It has to have a lot of dependencies that it needs to solve, so I don't necessarily have a bunch of opinions around it. So anyway, just follow me on CoderMonk, which is my Instagram handle. Just add the underscore at the end, or you can follow me on YouTube. The channel is CoderMonk, and check me out on LinkedIn and all of those places as well. Check me out this weekend on Unacademy platform. I might be doing a live session for the design pattern. I'll try to do a special class which runs for 2 hours, completely free. Just use the invite code, which is CoderMonk again, and you'll just be able to activate the whole thing for free. You can watch all the free classes there as well of other educators there. So I'm just gonna take off right now. It's been about I guess it's 9:05 in India, so I'm just gonna take off. Thanks again for joining, everybody. Hope this stream was useful. I'll see you again tomorrow's stream, where you're gonna talk about the concept of streams in that. Excuse me, guys. So we're going to be talking about streams in tomorrow's stream. So I'll see you guys there. Until then, it's Bharat. Peace out. Have a super awesome day.